For this problem, we have a mounting bracket with the dimensions given in our diagram, which is subjected to a 200-pound force. We are tasked with determining all of the internal forces and moments at this cross-section AA. So the first step in solving this problem is to separate this bracket from the wall and draw our free body diagram. So here we have our 3-inch dimensions, 4-inch dimensions, and our given 200 pounds acting at 35 degrees. And our first step is going to be to draw our internal forces and moments. So at point A here, we have a force in the AY direction. We have a force in the AX direction, that is at point A in the X and Y directions. And we also have a moment about our point A. Our next step is going to be to use our equilibrium equations to solve for these values, FAY, FAX, and our moment. So first I'm going to set up our forces in the X direction. So for our forces in the X direction, we have our FAX right here. We also have the cosine of 35 times our 200-pound force to get the X component of this force. And of course, all of this is equal to 0 because it's our equilibrium equation. So now we do a similar process, but in the Y direction. So we have our FAY given here, but this time we are going to have a minus 200 times the sine of 35, because we just want the Y component of this force, which is acting in the downward direction. And again, that equals to 0. And now what we can do is the same process again, but with our moments. So we have our moment at A, and then we have to take into account the cosine and sine components that we calculated here, but acting at the different distances. So we have a minus 200 times the cosine of 35, and that's going to act 3 inches away. And we also have a minus 200, but this time times the sine of 35, acting 4 inches away. And again, all of this is equal to 0. So now that we have all of our equilibrium equations set up, we can go ahead and start solving for our unknown values. So for FAX, rearranging this equation here, we have that equals negative 163.8 pounds. Again, solving for FAY, we have 114.7 pounds. And then same process for our moment. That will give us 950.35 pound inches or inch pounds. So now our final step is to draw our solution diagram. So here we have our arm, and we have our given 200 pounds, and then pulling from what we had solved for here at point A, we have our FAX, and since that is in the negative direction, it's going to point to the left, which is FAX equals 163.8 pounds. And then our FAY, which is positive, so that will point upwards, is 114.7 pounds. And then of course, our moment is positive, so that's going to go in the counterclockwise direction. So our moment at about point A is 950, and rounding 0.4 inch pounds or And that is our final solution.